Hello and welcome back to the course of Fundamental of Electronics and Electrical Engineering. In the previous video lecture of electrical machine, I have discussed about the three-phase induction motor construction and its working. In this video lecture, I am going to discuss about single-phase induction motor, its construction, different types of single-phase induction motor and working principle behind it, that is a double-field revolving theory. So first let us start with the single-phase induction motor introduction. The supply which we are getting in domestic application houses and domestic industrial applications are single phase supply. So all the appliances are of single phase, and so the electric motor used as domestic applications, small scale industrial applications are and housing applications are single phase induction motor, not three phase induction motor. So this is a common type of electrical motor which is widely used in domestic, commercial and industrial application. For the reason of economy, most houses, office and rural areas are supplied with the single phase AC supply. So motor used in that appliances are single phase motor. The power rating of such motor is very small as compared to the three phase induction motor. So single phase induction motors are having a number of domestic, commercial and industrial application, and domestic, commercial and industrial applications, housing are there, offices are there, rural areas are there, which are using single phase supply. So single phase induction motors are widely used. Now construction of single phase induction motor. So induction motor basically consists of two parts, rotor and stator. Stator is basically a stationary part, rotor is a rotating part. Construction of single phase induction motor is similar to that of three phase induction motor. Rotor construction is quite similar to that of three phase induction motor. It is identical to three phase squirrel cage type of induction motor. It's made up of laminated core, and the core cylinder kind of construction is there, which consists of skewed slots on its outer periphery, that we already discussed in the video lecture of three phase induction motor. The conductor and end rings are formed by forcing the molten copper aluminum in the slots. So copper bars are there in the slots, which are short circuited by the end rings. This is a squirrel cage type of rotor, which is quite similar to that used in the three phase induction motor. In fact, rotor of one phase induction motor is interchangeable with the polyphase induction motor. So rotor of three phase induction motor and one phase induction motor is quite similar. Now stator. As this is single phase induction motor, single phase winding will be there. Stator construction is identical. Stator core is identical to three phase stator core, which is in a hollow cylindrical form, which consists of slots on the inner periphery. Stator slots are there, which are uniformly distributed, but here one phase double layer winding is employed. As it is a single phase motor, only one phase winding is used, but winding is placed in such a way that it looks like a double layer winding. The single phase motor stator has a laminated iron core with the two windings are there. Winding is one, but it is divided into two parts which are arranged perpendicular to each other. One is the main winding, another one is a auxiliary winding or starting winding. So here you can see rotor construction is there, which consists of main windings are there, and starting winding is there, which is also known as the auxiliary winding. Main winding and starting winding are placed in such a way that both are displaced 90-degree electrical angle, and this is a stator frame. So this outside layer is nothing but the stator frame, and there is an air gap between rotor and stator. Now let us understand the operation of single phase induction motor. So one phase induction motor consists of one phase stator winding, which is mounted on the stator slots, and there is a squirrel cage winding is there, which is on a rotor. The rotor bars are short circuited by end rings. Now when stator is energized by single phase supply, it produces alternating current in the stator winding, and because of the alternating current, alternating flux will be produced in the stator, and this alternating flux cuts the rotor conductor. Now as only one winding is there, one phase supply is there, only one alternating flux will be there. So there will be two cycle, positive cycle and negative cycle. Now during the positive cycle of the flux induces a voltage in the rotor as per the Faraday's law of electromagnetic induction. Now Resultant, because of that, torque will be produced in the rotor and rotor will tend to rotate in one particular direction. Now, during the negative cycle of the flux, torque will be produced also in the rotor conductor and that will try to rotate the rotor in the opposite direction. So in the one cycle, rotor will rotate in one direction. In the other cycle of the flux, in the negative cycle of the flux, rotor will try to rotate in the opposite direction. So rotor is subjected to rapid reversal flux in the case of single phase induction motor, and due to inertia it will not rotate, and that's why single phase induction motor is a not self-starting, and this type of torque is a pulsating torque. Pulsating torque means what? It is having a equal positive and negative cycle, so net torque will be zero, so rotor will not rotate. So that's why single phase induction motor is not self-starting. Three-phase induction motor are self-starting because of the rotating magnetic field. Here pulsating torque is there, only one flux is produced and flux is having an identical positive and negative cycle, so rotor will not rotate. So we have to do some arrangement, that's why we have to provide some kind of spinning action, spin, so that rotor will start to rotate in one particular direction. So before understand how spinning is provided, let us understand principle of double field revolving theory, which is necessary to understand before we understand different kind of single phase induction motor. So what is the double field revolving theory? So according to the double field revolving theory, any alternating quantity, flux or current, can be resolved into the two rotating components, and these two rotating components are rotating in opposite direction, and these two rotating components are having half of the magnitude of the alternating quantity. So any quantity can be resolved into the two components which are rotating in opposite direction, and each component is having half of maximum magnitude of alternating quantity. Now, to understand that, here one alternating flux which is having a maximum value phi m is taken. You can see there are two components of that, which flux components are there, A and B, and which are having a equal magnitude phi m by 2, phi m by 2, which are resolving in anticlockwise and clockwise direction respectively. Now, when after some time both A and B would have rotated through an angle theta, you can see here. Now A and B are rotating in opposite direction, both have rotated, both are rotating with the same speed, so both have rotated theta angle. So the value of the resultant of A and B can be found using parallelogram. The resultant flux would be 2 into phi m by 2 cos 2 theta by 2, where phi m by 2 is the sides of the parallelogram, that is A and B. So resultant flux is phi m cos theta. So we can say we are getting the original flux back. So we can say any alternating flux can be resolved into the two component. Now, after quarter cycle of rotation, both are now in this position, YY position. Flux A and B will be exactly in opposite direction. So resultant flux will be zero because both are having same magnitude and both are in opposite direction. Now after half cycle, A and B will have a resultant of minus 2 phi m by 2 into phi m by 2, that is minus phi m. Now in the figure D you can see both have rotated now half cycle. So resultant of this can be also found using parallelogram, which will be minus phi m, which is in opposite direction. And after 3 quarters of the cycle, now again both are reaching over here after 3 quarters of the rotation, and the resultant flux will be zero, and so on. So any alternating quantity can be resolved into the two components which are having half of the magnitude of the alternating quantity, and both are rotating in opposite direction. And if we plot the value of the resultant flux against the theta and a value of theta between 0 to 360 degree, then curve which we are obtaining this kind of curve, and this is nothing but the pulsating curve. So that's why alternating flux can be looked upon a composed of two revolving fluxes, each of having half of the value and revolving synchronously with same speed in opposite direction. Now suppose flux in one direction is a forward flux, then that in other direction will be backward flux. So slip with respect to forward flux is given by SF is equal to NS minus N divided by NS is equal to S, and that with respect to backward flux is given by SB is equal to NS minus N, because now speed of the backward flux is in opposite direction. So SB will be NS minus N divided by NS. So NS plus N divided by NS, that equal to 1 plus N divided by NS, that is equal to 2 minus S. So forward slip is S and backward slip is 2 minus S. Now moving towards the torque slip characteristics. So here you can see one figure is there which shows the both the torques, resultant torque for the slip between 0 and +2. Now at standstill, the value of S is 1 that we already discussed in the previous video lecture. So forward slip is equal to S is equal to 1 and backward slip is equal to 2 minus S is equal to 1. So both the torques, forward torque and backward torques are equal, but both are in opposite direction. So it will produce no resultant torque. So rotor will not rotate. Here you can see torque is 0, net torque is 0. So rotor will not rotate. Now if rotor is start to rotate by in one particular direction, say in the clockwise direction by some spinning mechanism, then clockwise torque will start to increase and anti-clockwise torque will start to decrease. And hence there is a certain amount of net torque in the clockwise direction, and because of that motor will try to rotate. Rotor will rotate at this full speed in one particular direction. So some spinning mechanism should be provided to the one phase single phase induction motor so that it will start to rotate in one particular direction. So let us see how single phase induction motor can be self-starting, can be made self-starting. So to make the motor self-starting, it is temporarily converted into two-phase motor during the starting period. So winding is divided into the two parts. Here we have already discussed the main winding and starting winding will be there. So for this purpose, stator of the single phase motor is provided with extra winding which is known as a starting winding. In addition to the main winding, and two windings are displaced 90-degree electrical angle from each other and are connected in parallel across the single phase supply. And because of these two winding, two fluxes will be produced which are 90-degree displaced from each other, and so resultant flux will be there in one particular direction and resultant torque will be there in one particular direction. So it is arranged in such a way that phase difference between the currents in two stator winding is very large. Ideally the angle between the two currents should be 90-degree. Hence the motor behaves like a two-phase motor, polyphase motor, and these two currents, alternating currents or flux, produces a revolving flux, and hence motor is now self-starting. So instead of single flux, now we are having the two flux because of the two windings. So motor becomes this self-starting. So revolving flux will be there rather than pulsating flux. Based on the starting mechanism used, single phase induction motors are classified into the split phase induction motor, capacitor start induction motor, capacitor run induction motor, and shaded pole induction motor. So let us understand each and every one by one. The first one is a split phase induction motor. So as the name suggests here, two windings are there, main winding and starting winding. Starting winding is also known as the auxiliary winding. Main winding and starting windings are connected in parallel across the one phase supply. The main winding is having a low resistance and a high reactance. So main winding is basically high inductive, and starting winding is having a high resistance. So starting winding is highly resistive, main winding is highly inductive. Resistance of the starting winding may be increased by connecting one resistance in series with the starting winding, and which can be variable resistance can be connected, which the value of which can be varied, and by choosing the high resistance fine copper wire for winding purpose. So two ways winding resistance of the starting winding can be increased by selecting the copper wire having a high resistance, or by connecting one potentiometer in series with the starting winding. Now here you can see, when we apply the one phase supply across the main winding and starting winding, current will start to flow. Im is the current flowing through the main winding and Is is the current flowing through the starting winding. Now as I told you, main winding is a highly inductive winding, so current will lag behind the voltage by large angle. Starting winding is a highly resistive winding, so current will lag behind the starting applied voltage by some angle phi. Now the resultant of Im and Is can be found using parallelogram method, that is I. The angle between Im and Is is phi, alpha. Here you can see, the larger the angle between the two currents, the larger the torque can be produced. The angle between Is and Im is made as large as possible because the starting torque of the split phase induction motor is proportional to the sine alpha, the angle between that two. And now here you can also see the one centrifugal switch is also connected in series with the starting winding. Now what is the purpose of the centrifugal switch over here? So it is located inside the motor. Its function is to automatically disconnect the starting winding from the supply when motor reaches to 70 to 80% of the full load speed. So when once here starting mechanism spinning is provided by the starting winding, so once motor is start to rotate and rotor achieves the 70 to 80% speed of its maximum value, then or centrifugal switch will work and it will be in open condition. So starting winding will be disconnected from the single phase AC supply. Now only one winding is there, that is the main winding which is running on single phase supply. The purpose to disconnect the starting winding is to minimize the losses because of the starting winding. Starting torque of the split phase induction motor is 150 to 200% of the full load torque. The starting current is 6 to 8 times of the full load current. Applications are fans, blowers, centrifugal pumps, washing machine, domestic refrigerators, oil burners. There are a number of applications of split phase induction motor. So because of the splitting of the splitter winding, now single phase induction motor is becoming self-starting. Now moving towards the next one, that is a capacitor starts induction motor. So as the name suggests, here one capacitor is used which is connected in series with the starting winding, and centrifugal switch is also there. One phase supply is given to the parallel combination of starting winding and main winding. Now phase difference between IS and IM can be made large by connecting one capacitor in series with the starting winding. Because if the phase difference between IS and IM will be large, then large starting torque can be developed. Capacitor is generally of electro type and it is usually mounted on the outside of the motor as a separate unit. Here capacitor is designed to give the short duty service when centrifugal switch, when motor will reach to 75 to 80% of full speed, centrifugal switch will be operated. It will disconnect capacitor and starting winding from the main supply. So only main winding will be there, which is running only one phase supply. So here spinning is provided by starting winding and capacitor. Here purpose of the capacitor is to provide the large angle between IS and IM. This is a phasor diagram. Now IS will lead the supply voltage by some angle because capacitor is there. So it is a starting winding is connected with the capacitor. So IS will lead V by some angle and IM will lag behind V by some large angle because main winding is a highly resistive winding. Now you can see here the resultant angle between IS and IM is very large, which is 80 degree, and in the case of split phase induction motor, that is a 30 degree. So as the two currents are out of phase with each other by about 80 degree as compared to the 30 degree for split phase induction motor, and their resultant current I is very small and it is almost in phase with the V. So high starting torque can be developed in the case of capacitor start motor. The torque developed by split phase motor is proportional to the sine of angle between IS and IM. So it is obvious that increasing the angle from 30 to 80 degree increases the starting torque nearly to twice value that developed by split phase induction motor. So here starting torque is double as compared to the split phase induction motor. Improvement can be made to increase the starting torque about 350 to 40% of the full load torque. Now moving towards the next single phase induction motor, that is a capacitor start capacitor run induction motor. The construction is similar to that of capacitor start motor, but here one difference is that centrifugal switch is not there. You can see here starting winding and capacitor is there, but centrifugal switch is not there. So capacitor will be always connected. Capacitor will be connected in series with the starting winding all times. So advantage of leaving capacitor permanently in the circuit is improvement of the overload capacity of the motor. It gives the high power factor because capacitor is basically used to provide the for the purpose of power factor improvement. It gives the higher efficiency as capacitor is connected all times. It gives the quicker running operation of the motor, which is desirable for the small power drives in the offices and the laboratory. So smooth operation it provides as capacitor is connected all times. Typical applications are there: grinders, compressors, conveyors, fans and air conditioning, and refrigerator. These are the different application of capacitor start capacitor run induction motor. Here capacitor is always connected because centrifugal switch is not there, and because of that it gives the quieter operation, smooth operation of the motor. Now moving towards the last, that is a shaded pole induction motor. Now shaded pole induction motor have squirrel cage type of rotor, but stator is different. Here stator pole is divided into the two parts by keeping small slit. Here you can see rotor is similar to this squirrel cage type of rotor, but two stator poles are there which are stator pole is divided into the two parts by keeping small slit. Here one slit is there in the pole face. So in the pole face slit is produced. So pole face is divided into the two part, and the small portion is covered. Here you can see smaller portion is covered with the thick short circuited copper ring, copper wire. This is known as a copper band or shading band, and that's why it is known as a shaded pole induction motor. So pole is divided into the two parts. One part is covered with the copper band, that becomes the shaded pole, and other becomes the unshaded pole. And because of this arrangement, we will see that resultant flux produced by the stator winding will be rotating. So rotor will start to rotate. When stator winding is connected to the prime one phase supply, then it will produce is the main flux phi. This some amount of flux will be linking with the shaded pole. So shaded pole will work, and that flux linking with the second shaded pole will produces current in that. So secondary flux will be produced in the shaded pole, which is phi s. So both these poles, shaded pole and unshaded pole, will work as a primary and secondary, but secondary is a short circuited. The flux produced in the secondary will be phi s. Flux produced in the unshaded pole will be phi n. Now when alternating current is passed through the winding surrounding the whole pole, axis of the pole will be shifting from unshaded pole of the shaded pole, here from A to B, and because of that there will be a rotating flux, rotating kind of flux, and rotor will start to rotate. And this shifting of the magnetic axis is equivalent to the actual physical movement of the pole. So rotor start rotating in the direction of this shift, and from that is from unshaded pole to the shaded pole, and the rotor becomes the self-starting. Now when the alternating current tends to increase, it induces the current in the shading coil by transformer action in such a direction to opposite grade. So when flux density decreases in the shaded pole, when current increases, flux density in the shaded pole increases when current decreases, according to the Lenz's law. Now to understand that, here you can say one cycle of the current is taken alternating current, and that is in duration of that cycle is OC. Now current is increasing from OA, here you can see. This will produce EMF in the shaded band, shaded pole. As a shading coil is having a low resistance, large current will be set up in such a direction according to the Lenz's law to oppose the rise of the exciting current, which is responsible for its production. So flux mostly shift towards the unshaded pole, and the magnetic axis lies in the middle of this part, that is NC. Now consider the increasing current from A to B. Here the change in the current is negligible, so it is reaching to its peak value. So change in the exciting current is very low, so no voltage and no EMF is induced in the secondary coil. So flux will be distributed uniformly throughout the pole, whole pole. So main flux lies in the center of the pole, that is about along ND position. The last one, now current start to decrease along BC curve. So as current will start to decrease, the flux produced in the shaded pole will be phi s, that will be also low. That flux produced in the shaded pole will try to oppose this decreasing current. So there is a crowding of flux in the shaded pole, you can see here. So this current will flow in such a direction to oppose the decrease in the exciting current, with the result that flux is strengthened, that there will be more number of flux line in the shaded part of the pole. So magnetic axis now shift towards the middle part of the shaded pole, that is NE. This kind of motor is having a low efficiency, low power factor, low torque, and that's why it is used in small application like toy motors, hair dryers. These are the different application of shaded pole induction motor. So we have discussed four type of single phase induction motor: split phase induction motor, capacitor start induction motor, capacitor start, capacitor run induction motor, and finally shaded pole induction motor. So this is all about the today's video lecture. In this video lecture, I have discussed the different kind of induction motor, say single phase induction motor, how single phase induction motor can be self-starting, and double field revolving theory. Hope you have enjoyed the video. See you soon in the next video of the electrical machine. Thank you for watching.